Hello, this is Mr. Kizik, and in this video we're going to be talking about the properties of rectangles. So as we go along here, these properties really just do add to each other. So rectangles have the same properties as parallelograms. Still opposite sides are congruent, still opposite sides are parallel, still opposite sides are congruent. Opposite angles are congruent, still consecutive angles are supplementary, and still diagonals bisect each other. But there are two new things that actually make a rectangle a rectangle. So the first thing is that it has 4 right angles. And again, when we talk about these right angles, we're talking about the corners. And not only do the diagonals bisect each other, the diagonals here in a rectangle are congruent. So unlike a parallelogram where before we couldn't say that, oh, well, since that side was 22, then the other diagonal had to be 22. Parallelograms, that wasn't the case, but rectangles, now you can make that assumption. So adding more properties actually helps, for the most part, the math. So let's look at number 1 here. Number 1, they gave you PQ is 24 and PS is 10. Notice this time they didn't give us any diagonals like the parallelograms, and it is for a reason, which we'll see in a moment. So that means QR is 10 because it's opposite PS, and SR is 24 because that's opposite PQ. So that's nothing new there. But now we're trying to find SQ, which is this diagonal here. Unlike the previous problems where they gave us half of it or the entire thing or whatever, we were able to figure it out. But this time we're not given anything. So how do we figure that out? Well, let me draw something out for you here. I want to trace something down. What kind of triangle do I have here? Get it now? I have a right triangle. So what formula have you learned in the past here to deal with a right triangle? Hopefully you remember the Pythagorean theorem. A squared plus b squared equals c squared, where c is the hypotenuse and a and b are really interchangeable. So here, which part of this triangle is the hypotenuse? That's right, it's SQ. So to find SQ, I would have to do 10 squared plus 24 squared equals, and we'll call it x squared. And then it's just a matter of, solving for x or SQ. So 10 squared is 100. 24 squared is 576 equals x squared. I add them both together. I get 676. And then take the square root of both sides. Now, most of the time, you're not going to get a perfect square. Now, in this case, you do, because when I take the square root of both sides, I do get 26. Just realize that most of the time you're going to get a decimal. And if that's the case, then just round it to the nearest tenth. That's fine. All right. So SQ is 26. Well, what does that mean PR has to be? PR also has to be 26 because of that property that diagonals are congruent. And then QT, well, if I look here, QT is from here to here. What do we know about that? Well, QT is half of that diagonal, and as the property still applies, diagonals bisect each other, QT must be 13. And that's how you do a problem like that here to find the sides. Now, number 2 is the same thing. I just want to show you something that's different. We know AC is going to be 30 because it's 15 AE, so EC has to be 15, so AC is 30. BD is going to be 30 because diagonals are the same. BE is going to be 15 because it's half. AB is 27 because it's the opposite side. But now I want to find BC. So again, I have a right triangle. Still using the Pythagorean theorem, C, remember, is the hypotenuse. Now in this case here, we do have C. We do have the hypotenuse BD, which is 30. So my setup this time would be 27 squared plus x squared equals 30 squared. All right, so that's the only difference there. And, I mean, you guys can do the math there. The rest of it's algebra. I would just have to do 30 squared, which is 900. And then minus, I had to do 27 squared, which is 729. So 900 minus 729. Use my calculator to the side here. I get 171. And then I have to take the square root of both sides. And like I said, most of the time you're not going to get perfect squares like in this case here. It's going to be around 13.1 when I put it in the calculator. So that's how you work with the side lanes here. Now let's talk about the angles. Unlike the parallelograms, which, let's be honest, they were difficult because you weren't given too much to go off of here. While it still shares the same properties of parallelograms, the one new one with angles, which is 4 right angles, actually does quite a bit to help you out here. So they gave you just KJL, and that's really all you need. Because if I look here, MJK, if I trace this out, M to J to K, that's that whole corner, right? Well, what's that new property tell me about rectangles? It tells me the whole corners of rectangles is 90 degrees. So by the definition, by the property, it's 90. What's MJL? Well, if I trace that out, MJL will be this part right here. Just like before, if I knew this entire angle measure and I know part of it, I could figure out the other part because 2 parts make up a whole. Well, I know the whole thing is 90. So to find MJL, I'm going to take 90 minus 27, and that's going to give me what? 63 degrees. So 63 is right here. Let's see, JLK, which is right here. Well, we still have the alternate interior angles we talked about, so that is also 63 degrees. KML. Now, if I look at KML, you might be thinking, well, I know this is 27 right here because of alternate interior angles, but how am I supposed to figure out the other one? Realize what we talked about before. The opposite triangles in a parallelogram, which includes a rectangle, are the same. So that means KML also has to be 27 degrees. And then there's another reason too, which we'll see in the next problem. MNL, well, to find the middle angle, so to find this part right here, well, what do I know? What kind of figure do I have here? I have a triangle, and we know triangles add up to 180, so I could take 180 minus the two 27s added together, and that would get me the angle MNL. So let me just do my calculator here. So 180 looks like minus 54, and that's going to give me 126 degrees. Let's look at another one here. Let's look at number 4. So this time they gave you the middle. All right. So it's a little bit more math involved. So I want to look at for XWY. I want to look for this angle right here. Well, unlike the other previous problem, they gave you a corner. I don't have alternate interior angles here, so I need to do something else. What kind of triangle do I have here? In fact, all 4 of these triangles, what are they? Well, if you think about it, these are all isosceles triangles. Remember, isosceles triangles have 2 sides that are the same. But if not only are 2 sides the same, but also 2 of the angles, or base angles, if you recall, are the same. So to figure out those angles, I would do 180 minus 64, which would give me 116, right? Yeah, 116. So that means the two angles that are the same have to add to 116. So then I divide that by 2, and I get 58 degrees. So 58 degrees is right here and also right here. Which then means yxz, to find that angle, just use a different color. Remember, this whole corner is what? It's 90. So I do 90 minus 58, which is going to give me 32 degrees. It's 32 right here. Let's see what else do we want. Oh, WVZ, which is this angle right here. Well, what can I get away there? What do I have here? I have a line, so I would do 180 minus 64, and that would get me 116. XWZ is that whole corner. That's nice because we know it's 90. And then XZY would be, let me just look here, XZY would be right here. That's alternate interiors, so that would be 58 degrees. Okay. So that's how you work with sides and angles of a rectangle. So we're going to end the video here, actually. And what I want you to do is to try number 5 here on your own. And then, once you feel like you're pretty good with that, then watch part 2. Just have the answers there.